Okay, 7.6, it's really section 6.6 in your book, but this is unit 7. Law of cosines, this is just kind of an addition onto the last lesson, which was law of sines. We can use law of cosines to find missing sides and angles of triangles, and they don't have to be right triangles. And then we're going to talk about finding the area of triangles when we may not know the height. So, just a real quick review of when to use what. Because there are different instances where you're going to use a law of sines or a law of cosines. It depends on what information you've been given regarding the triangle. So law of sines, you're going to use that when you're given angle, side, angle, or when you're given angle, angle, side. Now, the ambiguous case we talked about with the law of sines, where sometimes you can have more than one triangle, you can have no triangles at all, would be side, side, angle. That was the ambiguous case. Those are the instances where you're going to use law of sines, which we talked about last time. For law of cosines, here, if you have side, angle, side, or side, 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 this is when you're going to use law of cosines. Another thing to think about, for law of sines, if you're going to use law of sines, you have to know an angle and a side across from it, which would fit all of these cases here. If you know all three sides, or if you have an angle but you don't know the side across from it, that's going to be an instance where you use law of cosines. Now, for sake of time and interest, the derivation of the law of cosines, not that it's so much more difficult, it's just a little bit more cumbersome to prove arithmetic-wise, so rather than trying to prove it, just jump right into it. Here's the law of cosines, and just like the law of sines, there are different instances where you might use one piece of the law of cosines or another piece, depending on what it is you're trying to find on the triangle. So the whole entire law, here we have a squared, and since it's lowercase a, this is talking about side a, is equal to b squared plus c squared minus 2bc times the cosine of angle A, or version 2, b squared equals a squared plus c squared minus 2ac times the cosine of angle B, or version 3, c squared equals a squared plus b squared minus 2ab times the cosine of angle C. And this is the law of cosines. Which one of these you use depends on what it is you're trying to find on the triangle. For example, tunnel is to be built through a mountain to estimate the length of the tunnel surveyor makes the following measure. So here we've got this big giant mountain here. Some guy standing on top yodeling. And there's this tunnel that needs to be built through this base of the mountain here. So the surveyor determines a point A and a point B. And the surveyor himself is here, point C. Now, using his surveying equipment, from here to here is 212 feet. From here to here is 388 feet. The angle between the two is 82.4 degrees. So the question then is, what's the length of the tunnel going to be? Now we have to really determine which, I mean, obviously this is in the lesson involving law of cosines, so it's a pretty good bet we're going to have to use law of cosines here. But on a test, you're going to have to make that decision, whether to use law of sines or law of cosines. So we've got to determine what we have here. Here we have a side, and we have a side, and the angle is between the two given sides. That's an instance of side angle side. What's been shown here is a side angle side case, so that's going to be law of cosines. And now we have to determine what it is we're looking for. We're looking for side C, because it's across from angle C. So I got to go back up here and decide which one of these three versions of the law of cosines is going to best fit our needs, and it turns out to be this one in red. We're searching for C. We're going to leave that as a unknown. But if C is an unknown variable, that means we have to be able to fill in all the other variables here, because we can only solve an equation if it has one unknown. So we've got to make sure we know side A, side B, and angle C. And we do. This is side A over here. This over here would be side B. And we know angle C. So we're going to use this version. C squared equals A squared plus B squared minus 2AB times the cosine of C. All this really turns out to be is a plug and chug equation. We plug in the values that we know, chug along until we find out what the answer is. So since we don't know C, we'll leave that as C squared. This is 212 squared plus 388 squared minus 2 times 212 plus 388 times the cosine of 82.4. So this turns into a calculator problem. Comfortable doing it all at once, you can tie this whole thing into your calculator as long as you're careful. 212 squared plus 388 squared minus 2. These in parentheses. Make sure I'm in degree mode. Messed up there, that should be a minus. And that's not the right. Let me try this again. See, if you're careful, you can type this all at once. I wasn't careful. 212 squared plus 388 squared minus 2 212 388 is the cosine of 82.4. There we go. So 173,730. So C squared is 173,730 0.236, I think it was. Square root both sides. And 416.8. 416.8 feet would be the length of the tunnel. Let's take a look at example 2. So given the diagram of a triangle, draw this triangle here. Label this vertex A, vertex B, vertex C. That length is 5, this length is 8, and this length is 12. So we need to find the angles. So choose one of them first. You know, just go in an alphabetical order here to solve for angle A. So since we're solving for angle A, which version we're going to use? Well, we got to use a version that involves angle A, so we're going to use this as our unknown. A squared equals B squared plus C squared minus 2 BC is the cosine. Okay. Now we got to correctly identify A, B, and C. If this is angle A here, then this is side A. This is side C, and so over here is side B. So this turns out to be A squared, it's 5 squared, 25 plus 64, it's 144 minus 2, is 8, is 12. And we got to think ahead and anticipate here. What is it going to take to find angle A? Well, eventually we're going to have to use an inverse cosine because angle A is inside a cosine function. So before we can take an inverse cosine, we have to isolate this cosine function right here. So we need to move everything else to the other side of the equation. So 64 plus 144, add that together, subtract that from 25, then divide by negative 2 times 8 times 12. And this is something you guys ought to be practicing doing. So go ahead. What you waiting for? The cosine of A should be 183 divided by 192. I got to think for a minute, is this even inside the domain of inverse cosine? Because we're going to have to take an inverse cosine on both sides. Is it possible to take the inverse cosine of 183 divided by 192? And the answer is yes. This would be a fraction less than 1, whose value is less than 1. That's the nice thing about the law of cosines, is there is no ambiguous case like there is with the law of sines. If you're trying to find an angle and you're using law of cosines, you don't have to ever ask, well, does this really work? Maybe there's 2 different angles. It will always give you one angle. So take the inverse cosine now on both sides. It turns out that angle A is about 18 degrees. Now we choose another one. Let's go for angle B here. So to find angle B, we're going to use another version of the law of cosine. It's going to be B squared equals A squared plus C squared minus 2 AC is the cosine of B. So this is going to be 64 equals 25 plus 144 minus 2 times 5 times 12 times the cosine of b. Doing the same thing, moving all these terms to the left side so we can isolate cosine of b. We're going to get eventually cosine of b is equal to 0.875. Taking an inverse cosine on both sides, we get the angle B is about 29 degrees. Now at this point we can stop using law of cosine because there's only 180 degrees in a triangle, so if we add the two that we have and subtract from 180, 18 plus 29, 47, we'll subtract that from 180, we get 133 degrees. Let's go into area. One formula that you're all familiar with, area is equal to 1/2 times the base times the height. That's a formula you learned in geometry. Back in section 6.3, we learned, or maybe it was 6.2, can't remember where it was, but we learned another area based on finding the height of the triangle in terms of sine, because sometimes it can be even a triangle and you don't know the height of the triangle. So another formula could be area is 1/2 times side A times side B times the sine of the angle included by side A and B. Now, in the case where you don't know any of the angles in a triangle, how do you find the area? There's got to be a way to find that, because using law of cosines now, we're able to use law of cosines. In the case where we have all three sides but no angles, we could use law of cosines to find angles, and once we have angles, we could then use this formula here. Now, if you didn't want to go through that trouble, there is something called Herons. Formula for the area of a triangle. Area is equal to the square root, no, it's not square root, of S times S minus A times S minus B times S minus C, where S is equal to the sum of the sides divided by 2. That's called the semi-perimeter. So if you add up all the sides of a triangle, that's the perimeter. If you divide that in half, that's called the semi-perimeter. So you really have two options here. If you're given three sides of a triangle, you can use Heron's formula, find the semi-perimeter, and then find the area that way. Or you can use law of cosines to find one of the angles of the triangle. Once you know one of the angles, you take the two sides that include that angle and then use this formula here, 1/2 AD times the sine of theta. Let's take a look. So if we have a triangle like this, 125, 280, 315, and we need to find the area. One way to do this using Heron's formula, first find S, so that would be 315 plus 280 plus 125. Divide that by 2. That turns out to be 360. So then using the formula, area is equal to the square root of 360 plus the difference of 360 now and all the corresponding sides. So 360 minus 125 times 360 minus 315 multiplied by 360 minus 280. So type this into your calculator. If you're careful, like I wasn't the last time, I'll try better this time. Type it in all at once if you want to. 360. Make sure to put all the rest in parentheses. 360 minus 125. 360 minus 315. And make sure these are all underneath the square root. So it turns out it's about 17,451.6 for the area. Now if you're worried about memorizing an additional formula, because you're going to have to memorize the law of cosines, the law of sines, and there's all these other area formulas, if this is making you nervous to memorize Heron's formula, you could apply law of cosines and find one of these missing angles. This angle, for example. You could find angle alpha using law of cosines. Using that, you could use the two sides included that angle, so 315 and 125, and you can use the formula area is equal to 1/2 AB times the sine of that angle here. So this would be half of 315 times 125 times the sine of whatever that angle. And to find this angle, you have to use law of cosines. It might help to label the triangle with vertices. But those are your options regarding finding the area of a triangle if you don't know the height. If you know all three sides, you can use Heron's formula. If you know two sides and the angle included between those two sides, you can use that other area formula.